Hey there, and welcome. Today, we're going to peel back the layers on some everyday objects you think you know and reveal a hidden world of absolutely mind-blowing complexity. So let's just dive right in.
So, think about these things for a second. A plastic bottle, an egg carton, even a car bumper. You've probably got at least one of these within arm's reach right now. They seem so simple, right? Maybe even disposable. But what if I told you they all share a secret, and it's a pretty complex one?
You got it. Every single one of these items is the final piece of this huge, intricate industrial puzzle. We're talking about a process that involves intense heat, incredible pressure, and a logistical ballet that is just, wow. It's something else.
So let's get into it. The first piece of that puzzle is, how are these things even made? Well, it all kicks off with a process known as plastic molding.
Okay, so the basic idea is pretty simple, right? You take these tiny little plastic pellets, you melt them down into a hot liquid, you squish that liquid into a specially shaped container, that's called a mold, and then you cool it all down until it becomes a solid object. Sounds easy in theory, but in practice, it's pure industrial artistry.
And of course, you can't make a car bumper the exact same way you make a thin water bottle. Different products need different, well, recipes, you could say. Or in this case, different molding methods. We're going to take a look at the 4 big ones.
And here's our lineup: injection, extrusion, blow, and vacuum molding. Now, each one of these is specifically designed to create a certain kind of shape and to do it super efficiently. So let's break them down one by one.
First up, we've got injection molding. You can think of this one as the heavyweight champion. It's for creating solid, complicated, and really precise parts. It's kind of like a super high-tech, high-pressure syringe that's just filling a mold with molten plastic. And because it's just so precise, it is used for literally everything, from the bumper on your car to the plastic casing on your blender, and I mean countless other things we all use every single day without even thinking about it.
Next, we have extrusion molding. And the analogy for this one is just perfect. It's almost exactly like squeezing toothpaste out of the tube. The molten plastic gets pushed through a shaped opening, which is called a die, and that creates one long continuous piece. So anything that's really long and has the exact same shape all the way through, we're talking pipes, tubes, plastic films, sheets, you can bet it was made this way.
All right, our third method is blow molding, and this is how we get all those hollow things. It works pretty much exactly how it sounds, like blowing up a balloon. A little tube of hot, soft plastic is put inside a mold, and then whoosh, air is blasted into it. That forces the plastic out against the walls of the mold, creating the final shape.
So yep, that water bottle sitting on your desk, it was born from a little puff of air shot into a tiny plastic bubble. It's such a simple idea, but it's one that produces billions and billions of containers every single year.
And finally, we've got vacuum molding. For this one, you take a warm, kind of floppy sheet of plastic, lay it over a mold, and then you just suck all the air out from underneath. That vacuum pressure pulls the sheet down super tight against the mold, and boom, you've got your shape.
This technique is absolutely perfect for thinner products. Think about the food tray from your last takeout meal, or the egg carton in your fridge, or, that clear plastic packaging that is literally impossible to open. Yeah, that's vacuum molding. Okay, so now we know how a single plastic item gets made. But honestly, that's the easy part of the puzzle. The real challenge, the real headache, isn't making one. It's about making millions of them, perfectly and on time.
Because the second you try to scale up to an industrial level, this whole new universe of complexity just opens up. The really hard problem isn't the engineering, it's the scheduling.
And this brings us to the real heart of the whole puzzle, production scheduling. This is a relentless 24/7 battle against total chaos, where every single decision you make has this massive, unpredictable ripple effect. I mean, just imagine being a plant manager. You're juggling all of this at once. You've got these strict deadlines you absolutely cannot miss, but then a client calls. They have a last-minute rush order. A shipment of your plastic pellets gets delayed. A machine breaks down. One tiny little change, and the entire production plan for the next few weeks can just completely fall apart.
Now, to really get a feel for how tricky this is, let's zoom in on just 2 of the biggest, most complicated puzzle pieces that schedulers are dealing with every single day, something called changeovers and cavity counts.
Okay, so check this out. The changeover problem. Imagine one of your machines is pumping out black car parts, but the very next order on the list is for bright yellow parts. You can't just switch the plastic pellets. The whole machine has to be stopped, taken apart, and scrubbed completely clean. This cleaning can take hours, and those are hours where the machine is making nothing and you're losing money. So planners have to get clever and group all the colors together, usually going from light colors to dark ones, just to minimize that downtime.
And then you've got the cavity count. See, a mold doesn't just make one thing at a time. It might have, say, 8 little pockets, or cavities, making 8 bottle caps every single cycle. But what happens if one of those 8 cavities breaks? Well, all of a sudden your output drops by more than 12%. Your entire production speed is now wrong, your delivery date is in jeopardy, and the whole factory schedule might have to be thrown out and recalculated from scratch.
So, here's the real takeaway. That simple object you're holding in your hand isn't just a piece of molded plastic. It is the actual physical result of a massive, constantly shifting scheduling puzzle being solved in real time.
Think about it. From a tiny plastic pellet, through one of those very specific molding processes we talked about, all of it navigated through a logistical minefield of changeovers, deadlines, and 1,000 things that can go wrong. The next time you pick up a simple plastic bottle, just take a second and appreciate the invisible masterpiece of planning that it represents.
It really makes you wonder, doesn't it? What other invisible, incredibly complex puzzles are hiding out there in plain sight, in all the other simple objects we use every single day?